Hello, I'm JW. This time got this awful extension lead thing again, and we're going to be putting some power through this time and seeing what actually happens if it was put into effectively normal use. So we're not just going to shove current through and see if it burns, we're just going to collect some appliance to this and see what happens. Now I've removed the switch from the bottom here, mainly because in the previous video I saw that one of the wires actually broke off from the switch, and it turned out it was next to impossible to solder it back onto that. Goodness knows what metal that was made from. So all we've got now is basically two wires come in. One goes to the conductors there, and the other one goes to the conductors on that side. And I've also removed the alleged earthing things along the sides there, because they weren't connected to anything anyhow. And as was pointed out by several people in the other video, they were very close to the other two conductors, so all that would have happened there, something would have softened a bit, moved out of position slightly and shorted across the two, which of course would just take out the fuse. So basically just got that with the two wires, the despicable extra thin flex, which we saw has resistance for the two in the region of 4 ohms, so that's going to cause a substantial voltage drop and probably get fairly hot as well. So let's go outside and see what we've got. Now here we're outside, and the load we're going to be using today is this electric heater here, this silver thing. Now this is a fairly old one, and it's been in a few other videos previously. This is a purely resistive load, so it has a power factor of 1, doesn't have any capacitive or inductive elements. And then on the top here we can see various things I've got set up here, several testing meters and various cables and other wires. So let's just have a closer look at those. Now I've got 3 meters here. The yellow one on the left is showing the voltage, and that's actually at the incoming supply, so it's sort of the beginning of the extension cables we've got. And then the meter on the right there, the grey one, also shows the voltage, but this is actually where the heater is plugged in, and these will be able to show the difference in voltage between those 2 points, so we'll be able to find out what the voltage drop is across the extension lead. And then on the right there we've got the clamp meter, which will show the current, and I basically just split the wires there so we can just monitor the current, of course, in the line only, and that will show us the current going through the whole circuit. Now to start with, we'll just do the test here without the horrible extension lead in, so this is just the heater being plugged in, and the voltage we're measuring here is just across the normal wiring which we've got here. So if we just turn on, so see the voltage coming in is 241 volts AC, and of course on the outgoing side again it's also 241 volts, so of course it's the same. Current at the moment is 0 because the heater isn't actually turned on. So we'll just turn the heater on. So the heater's on. We'll see the voltage has actually dropped to 238, but it's 238 on both of those, so that's basically just from the actual supply itself. And we see the current on this one is 6.8 amps, so nothing particularly excessive there, just a fairly small amount of current. Bearing in mind that these extension lead things are normally rated to around 16 amps, so 6.8 or so there, massively within the capability of them. And the current there 6.8 and the voltage 238, that gives us a power rating of around 1600 watts or 1.6 kilowatts, and that's pretty much what the rating of this heater is, so again not entirely surprising. Now make a few changes, and this is what we've got. So we've basically put that dodgy extension lead into the circuit, so it's basically plugged in that white block at the back, and then our heater and other converting bits are plugged into the actual extension lead towards the front. Voltage and the current meters are pretty much the same as we had before, and the addition here now has got a thermocouple and the temperature meter there, and I've just cut the wire on the extension lead there, or slit the outer insulation, put the thermocouple probe inside, and we can see the temperature there on the black small meter towards the back. So the heater is now turned on, and we see the incoming voltage has dropped slightly to around 239. The outgoing voltage though is 214, and we can see the temperature in the middle is rising rapidly, already up to around 40 degrees centigrade, and it's actually increasing significantly and very quickly. Now the difference in voltage there is around 26 volts, and that's all being dropped pretty much across that dodgy extension lead, and because the current is 6.1 amps, that means that within the wires of the extension lead there's about 160 watts being dissipated, and pretty obviously that's going to get very hot very quickly, and we can see the temperature of course is continuing to rise beyond any kind of safe level. So we'll just continue with this there, and we see the current has actually dropped down now to 6 amps. The temperature now is 115 degrees centigrade, and it's still climbing very quickly. Now, of course, if this was plugged in your house, at the moment you wouldn't necessarily notice anything was wrong, other than the cable is obviously softening there and moving slightly. But clearly this is only a very small load, only around 6 amps or so. This thing claims to be rated for 16. So let's just leave this going and we'll see how it goes and where the temperature eventually gets to. Now see the temperature's now reached 200 degrees centigrade, and we can see already there's some smoke coming out from various parts of the cable. The cable itself has softened significantly. You can see in the middle there where the two pieces cross that the cable is actually deformed, where the two parts are just resting against each other. And as the temperature continues to increase, the amount of smoke coming out also increases. Bearing in mind that PVC insulation is only normally rated for around 70 degrees centigrade, this is now at 218. So it's already nearly 3 times the actual rating that the cable should be designed for. And as the temperature continues to increase, we can see more smoke is pouring out, and clearly this time somebody would notice something was extremely wrong. Now the voltage across the cable there, at the end of it, you can see we've only got 205, even though we've got that 239 going in, and the current has dropped now to around 5.8 amps. This basically because the resistance of the wire has increased, so therefore the actual heat dissipation in the cable has increased as well. And as we're approaching the 250 degrees centigrade mark, we see now there's huge clouds of smoke pouring off from all parts of the cable and the plug as well. Now the temperature is now at 270 and still climbing, and the power dissipation in the cable now is around 200 watts. See the voltage at the end there is now dropped down to around 203, and the current is about 5.8. And you see large amounts of smoke is pouring out of various bits of the cable. We can see various areas are now blackening, and as the insulation is sort of disintegrating and falling away from that. Bearing in mind this is only with a load of about 5.5 or 6 amps. Well within the claimed rating of this device, and certainly not an unusual load to find in, say, normal property. Now I'll disconnect the power there because it's pretty obvious that this is not going to last much longer, and of course if we left it on it's just going to melt through and short out some of the wiring, but the wiring is already pretty much destroyed, so we'll have a closer look and see what it's like. Now I'll let this cool and of course disconnected the power, and we can see here that the flex is disintegrating. The inside is sort of melted and the outside is basically deformed. That red bit is where the thermocouple was connected, and the whole thing is now in a sort of a nasty crunchy arrangement, and even the plug itself here, again the whole lot is totally wrecked. And this was only after a few minutes at 6 amps, nothing unusual about that. And see that big burn mark there where the two pieces were resting against each other. And that particular piece, if you just bend that there, you can see the inside is all sort of crunchy and crumbly. Basically it's just turned to a sort of black ash type material. Now of course we didn't actually see it burn there, but had we left it on, no doubt it would have done. Now what we've done here is just going to apply a flame to this to see if the material is self-extinguishing or not. And the point about this is it should be, so that if a flame is applied it may burn, but then when the flame is removed it should stop burning, so effectively it's not acting as a fuel source. So first we'll try the actual flex itself, so just apply the flame to the side of it here. See that it's blackening and burning away. But as we remove the flame it basically goes out pretty much straight away. So the flex itself is actually self-extinguishing. Just try another piece of it over there. So flames there, then of course the flames immediately disappear once the flame is removed. So that's actually a pass in that regard. Now let's try the actual body of the plastic thing itself. So again we'll just heat that up until flames and things appear. Now remove the flame there, But as you can see, the flame is still burning, so clearly this is not self-extinguishing, and this means the plastic is acting as a fuel source, and of course will continue to burn, and of course potentially set light to anything else that may be in the vicinity, such as your carpet, curtains or anything else. Now as you can see, it's still burning, despite the fact that the flame was removed quite some time ago. Now of course normally we should just put this out with some water or something, but this time we're actually going to leave this burning and see how long it actually takes before this thing actually goes out. So we'll just leave this going, and then we'll come back in a few minutes and see if anything's changed. This is about a minute later, and we can still see there's some small flames there. Now this is actually under artificial lighting, so I think what we'll do is just turn the light off, and then we'll be able to see the flames a bit more easily. So there we go, lights turned off, and of course it's still burning away, and in fact there's a flame seems to have leapt up there rather more ferociously. So again, still burning away. So this is after a minute or so of the actual flame source being removed. Here we are after another 2 minutes, and as you can see it's still burning pretty rapidly there. No change whatsoever. So again, if this had been in your house and you weren't around, this could be just burning and burning away and setting light to anything that's in the vicinity. Now just rejoining here, this is about 6 minutes after it was initially ignited, and of course once again you can see it's still burning away pretty fiercely there. Half of it has now turned into sort of weird white ash type material, but there's still plenty of plastic left. So even after 6 minutes this is still burning away, and of course would still be igniting and setting fire to anything happened to be around. Now this is after 12 minutes, and yes, it's still burning away, although there's not a huge amount left now. We've kind of got down to the last part at the end, but bearing in mind it was only ignited at one end, and despite that, 12 minutes plus later it's still burning away. So clearly this thing is basically effectively a fire lighter. It's nothing to do with any kind of self-extinguishing materials whatsoever. It's just a flammable chunk of whatever it's made from. Now I've reached the end here really, and there's still a small part amount burning at the end, but bearing in mind this is after 15 minutes, and despite that there's still some small flames flickering away at the end. So no way could this possibly be described as compliant or self-extinguishing. So it's finally gone out there. I'd say that took well over 15 minutes to do that, and now of course it's just going to sit there and smoke and smoulder for goodness knows how long. Now put that on the light again, and we can just see that what's left is basically this sort of white ash material. Flex is mostly intact, but the rest of it is basically completely gone. There's a bit left at the bottom here. We can just sort of pry that up with that screwdriver. This sort of gooey, gungy mess of what's left of the plastic material. So totally flammable, extremely dangerous, and even before that of course the current we put through was only an order of 6 amps, nowhere near its claimed rating of around 10 or 16. So that's the end of this particular piece of equipment, and it's also the end of this video. So until next time, thanks for watching.